Hello everyone. Welcome back to Sharp Study. Today, we are going to learn about one of the most important topics in Class 9 Science: motion. Motion is something we observe all around us: cars moving on the road, birds flying in the sky, trains running on tracks, and even the Earth revolving around the sun. What is motion? Motion is simply the change in position of an object with time, with respect to a reference point. For example, if you say, "My school is 5 kilometers away from my home," then your home is the reference point. Motion is always described with respect to such a point. Scalar and vector quantities. To describe motion, we use two types of quantities. Scalars, which have only magnitude. Examples are distance, speed, and time. Vectors, which have both magnitude and direction. Examples are displacement, velocity, and acceleration. If you say, "I am 6 meters away," it is scalar. If you say, "I am 6 meters away towards the park," it is vector. Distance and displacement. Distance is the total path length covered. It is always scalar. Displacement is the shortest straight line distance between the initial and final positions. It is a vector. For example, if you walk 5 kilometers east and then come back 5 kilometers west to the starting point, your distance is 10 kilometers, but your displacement is 0. Uniform and non-uniform motion. Uniform motion means covering equal distances in equal intervals of time. Example, a train moving steadily on a straight track. Non-uniform motion means covering unequal distances in equal intervals of time. Example, a car moving in traffic. Speed, velocity, and acceleration. Speed is distance divided by time. It is scalar. Velocity is displacement divided by time. It is vector. Acceleration is the change in velocity per unit time. It is also vector. If velocity increases, acceleration is positive. If velocity decreases, acceleration is negative or deceleration. Numerical example. An object travels 16 meters in 4 seconds, and then another 16 meters in 2 seconds. The total distance is equal to 32 meters. The total time is equal to 6 seconds. Average speed is equal to 32 divided by 6 is equal to 5.33 meters per second. Equations of motion. When acceleration is constant, these three equations are used. Example, a train starts from rest and reaches to 0 meters per second in 300 seconds. Acceleration is equal to 20 divided by 300 is equal to 1/15 meters per second squared. Distance is equal to v superscript 2, 2a, is equal to 400 divided by 2 times 1 divided by 15 equals 3000 meters is equal to 3 kilometers. Graphical representation. Distance time graph, a straight line shows uniform motion, and a curved line shows non-uniform motion. Velocity time graph, a horizontal line shows constant velocity, a sloping line upward shows acceleration, and a sloping line downward shows deceleration. The area under the velocity time graph gives displacement. Uniform circular motion. When an object moves in a circular path with uniform speed, it is called uniform circular motion. Even though speed is constant, the direction changes continuously, so velocity changes and the motion is accelerated. For example, when you rotate a stone tied to a string, it keeps moving in a circle. If you release the string, the stone flies off tangentially in a straight line due to inertia of motion. Summary. Motion is change in position with time. Scalars have only magnitude, vectors have both magnitude and direction. Distance is path length, displacement is the shortest straight line. Uniform motion and non-uniform motion differ in how distance is covered. Speed, velocity, and acceleration describe rate and change of motion. Equations of motion apply under constant acceleration. Graphs help us understand motion visually. Uniform circular motion is accelerated motion due to change in direction. Audience questions. Can displacement ever be greater than distance? Why or why not? Why is circular motion considered accelerated motion even when speed is constant? There are some questions for self-practice. Answer in the comments below. That's all for today's video on motion. If you found this helpful, don't forget to like, share, and subscribe to Sharp Study for more easy and clear science lessons.